Welcome to Miss North's mini geography lesson on plate boundaries. This image shows how our crust is broken into different plates. Where the plates meet is called a plate boundary. As you can see, most of our volcanoes and earthquakes occur on or near plate boundaries. This map shows the direction each plate is moving. The convection currents in the mantle are moving the plates ever so slowly in different directions. So today we are looking into what happens at each plate boundary. I suggest using this template to take some notes as we talk through each plate boundary. So if you want to press pause right now to note this down, please do. And please feel free to press pause at any time throughout the video clip to stop and take notes. So today we're going to look at our 4 plate boundaries. Now we've got 2 different types of crust. So our crust broken down into our plates. We've got our oceanic crust, which is made from basalt. It's very dense, it's very heavy, and this is found under our oceans, oceanic crust. I've represented that in our blue boxes. Then we have our continental crust, made from granites, and this is typically found under our continent, so under land, and I've represented this in our green boxes. Now some plates are so huge that they're made of both oceanic and continental, but I've picked some examples today and represented them in the colours that they are, so either oceanic or continental. So first off, we're going to look at our constructive plate boundary. So the example that's really great from this is our mid-Atlantic ridge, so the ridge in the middle of our Atlantic Ocean, deep under the ocean. So it's our constructive plate boundary where our 2 oceanic plates, our North American and our Eurasian, are moving away from each other. So away, pulling apart. And what happens here are volcanoes, typically shield volcanoes, because magma from our mantle is being forced upwards, where there's a gap now forming, creating new crust. And this builds up over time, creating a shield volcano, which we'll look at in another session. And also there's friction happening here as our plates are slowly moving, and this causes earthquakes. So a way of remembering this is constructive plate boundary is it's constructing new land. So the second one we're going to look at today is our collision plate boundary. Now this is where we have 2 continental plates, and the example that I'm going to look at today is the Himalayan mountains, fold mountains, and it's where our Indian plate and our Eurasian plate are moving towards each other. Now because these are both continental plates, there's nowhere for them to go other than to fold upwards. So just demonstrating this here, as they move in, it's forcing new land up. It kind of creates our fold mountains like that. So the way I remember that is collision, they're colliding towards each other. So number 3, our destructive plate boundary. This is where we have an oceanic crust and a continental crust moving towards each other. And the example that I'm going to use is our Nazca plate, which is oceanic crust, moving towards the South American plate, which is our continental crust. Now as they move towards each other, the oceanic crust is very dense, it's very heavy, so it's forced underneath our continental. So as this is forced underneath into our mantle, temperatures melt that rock again. It's called our subduction zone. Now this pressure builds up as the plates melt, and through any cracks or faults in the continental crust, it's forced upwards, causing our big volcanoes, our composite volcanoes. And also as these plates are slowly going under each other, it's causing a lot of friction, and we get our earthquakes here too. And a great example, as I said, is the Nazca plate and the South American plate. A good place to look is Chile. Okay, so destructive plate boundary is destructing land. Then finally, we have our conservative plate boundary. Now this is where we have 2 plates slowly moving against each other, and the example that I'm going to use is our Pacific plate and our North American plate, and this is happening at somewhere called the San Andreas Fault, which I'm sure you've heard of. There's a movie about this. It's in North America, California. So they're very slowly moving against each other. Now, as these move against each other, a lot of friction builds up and suddenly they might jolt, causing our big earthquakes. And a great way I remember this, it's always stuck in my head, is the Conservative plate boundary. It's related to our Conservative party where Theresa May was leading, and she was leaving the stage that one time and she did her funny dance. So you can remember Conservative Theresa May doing her dance because the plates are moving against each other. So that's our 4 plate boundaries. I really encourage you to look at Google Earth, to look at these places, see what you can see at the Mid-Atlantic Ridge. It really is quite interesting when you use the satellite image on Google Earth. But thank you for watching.